So let's discuss this problem, which is lead code 402 remove k digits. According to the question, you are given a number and you are given a value k. Now we need to remove k digits from the number, and we have to make sure that the resultant number is as lowest as possible. Now, one thing to remember is that we cannot swap the digits. Okay, so we have to maintain the order. So we have to remove k digits, maintaining the order of the digits. Okay, so as you can see in the example, the number is 1432219, and the value of k is 3. So we have to remove 3 digits, and the digits which are removed are 4, 3, and 2. So 4 is removed, 3 is removed, and 2 is removed, and the resultant number is 1219, and which is as lowest as possible. Now, how to approach this particular problem? And since we know that we have to maintain the order, so we have to keep a track of the continuous positions of the digits. And since there is a question of continuous positions, so the better data structure to approach this particular problem is the stack. Since we know that stack maintains a continuous position, and we can also use the double-ended queue dq for this particular problem, but I am taking a stack. Now let's see how to approach this particular problem with the driver. So before particular problem, let's take a simple example and discuss what our approach should be like. For example, if we are given a value 1 4, and there is a digit called 3, a digit 3, and given our k value is 1, so that is we can remove one digit, maintaining the order. Okay, order of the digits. So there are three possibilities, right? We can take 1 and 3 and remove the middle element, which is 4. So 4 can be removed. The second possibility is that we can take 1 and 4 and we remove the 3, right? 3 is removed. And the third possibility is that we take 4 and 3 and 1 is removed, right? Now, which of this gives the lowest possible value? The answer is this particular number. Now, as we can see from this observation is that we have to make sure that we maintain a sorted order of digits, right? We have to maintain a sorted order of digits. We have to remove k digits, maintaining a sorted order. And how we can maintain this? We can maintain this by keeping a track of all the previous digits. For any particular digit, we have to keep a track of all previous digits. And if our current digit is greater than the previous digits, then we can add it. But if our current digit is lesser than, for example, you can see here 3 is lesser than the previous digit 4, then we have to remove the previous digit to ensure that the number formed is the lower value. So we will use this particular thought process, this particular approach to solve this problem. So let's see how. So the index 0, uh, the k value is 3. We enter this 1 into our stack. The next element is 4. The moment we get 4, we scan the stack for all the previous digits, and we see that our 4 is greater than the previous digits, so we can easily enter 4. The next digit is 2. The next digit is 3 at index 2. So for 3, we have to keep a track of all the previous digits in the stack. So if we keep a track of all the previous digits, if we scan the stack, we see that our topmost element 4 is greater than our current digit. And since in the explanation I have told that we have to maintain a sorted order, so we can remove this 4 and our k value will be 2 since we have removed one digit. And then we scan the stack again and see whether 3 is greater or lesser than the topmost element, which is 1. Our 3 is greater than the topmost element, so we can enter 3 into the stack. Okay, now 3 is entered into the stack. Let's move on to the next position. The next position is index 3. The element is 2. Now again we scan the stack. We see the topmost element is greater than the current element, and since it is greater and our k value is 2, we can remove this topmost element, and since we have removed, we reduce the k value by 1. Again we check our current value with the topmost element, which is now 1. We see that our topmost element is lesser than the current element, so we can enter 2 into the stack. Now 2 is entered into the stack. We move on to the next position, which is uh, at index 4, which is again 2. Now 2 is checked with the topmost element of the stack, which is 2. Now it is equal. We can enter this 2 into the stack. Now we move on to the next element, which is 1. Now 1 is checked with the topmost element, which is 2. Now 1 is lesser than the topmost element, so we have to remove this 2 from the stack. And since we have removed 2 from the stack, our k value will reduce by 1 and it will reach 0. The moment it reaches 0, that means we don't have any more k values, that it we have exhausted the number of deletion option. Now we again check 1 with the topmost element, which is 2. Now 1 is lesser than 2. 2 should be removed. But since we have used up all the possible k values, there is no more deletion option. Therefore, we have to enter 1 into the stack. The next element is 9. The 9 value is greater than the topmost element, and that doesn't matter because our k value has already reached to 0, so therefore we have to enter 9. Now if we pop out all the elements, 9, 1 and 2 and last is 1, so we get our answer, which is 1219, which is basically our answer. Now while solving this problem, there is one more special case which I want to share. This is that special case. Suppose if you are given a number where every digit are same, and if suppose the k value is 2 and the number is 111, all ones, then you will get something like this in the stack, right? And then what we'll do? We have to remove k digits from the stack in this particular scenario. So we'll have a check in the coding section for this particular special case, to handle this particular special case. So this is a corner case. So I'll show in the coding section how to handle this particular special case. So let's see the code. I have taken stack and also have converted the number to character array so that it becomes easier to iterate. As I have mentioned in the approach, for each of the digit, I am checking whether the previous digits are greater than the current digit or not. If so, and if our k value is greater than 0, then we have to remove uh, the previous digit from the stack and k minus minus, and then we enter the current digit to the stack. This is the special case which I am talking about. Suppose your stack contains something like 1111 and your k value is 2. In that particular case, this code will shoot where you have to remove k elements from the stack. All right. And after that, we have to form the digits. We have to form the number from the digit. For this, we have taken string builder SB. Basically, what it does is that if suppose your stack contains something like 142, so it will concat that and make 241, right? After this reverse, you will get the original number, which is 241. And this particular section handles the leading zero. For example, if you have something like 0 0 2 and 0, then you will get 0200 when you form the string, right? Now this particular section contains leading 0 and we have to remove that. So this particular section of the code handles this particular case where there are leading zeros and it removes them. And after the leading zero is removed, you have to return 200. Now this is again a corner case. If suppose your digit consists of only zeros, then your length of the string builder will be obviously 0, since it removes all the leading zeros. So in that particular case, you have to return 0. Otherwise, you return the string formed, right? So I'll attach the link of the code in the description section as well.